Hi, my name is Jay. I'm from Samsung. And the topic is smart home appliance development based on the IoTivity Stack. With this presentation, I'm about to share the tips that I have experienced during implementing the home appliance development. So I wish you could get useful information during or after this presentation. Okay, this is the content. I'm going to explain about the preliminaries of the development, and then explain the target devices that I worked on, and then the steps that you need to follow when you want to implement application based on the IoTivity. Okay, this is the preliminaries. I think you might already get explained about this programming model of the IoTivity in the morning and the afternoon as well. So let me give you the brief explain about the programming model of the IoTivity. IoTivity supports resource-oriented server-client model, meaning resource server has a lot of resources, and the client can discover resource on the network and use those resources in order to communicate with the server. And IoTivity provides a RESTful side of interface, which is similar to the web interface. Those are the get, put, post, and delete. And there's one extra request type, which is Obseve. Obseve is a get request with a special flag, which is Observe flag. So if the client send the get request with the Observe flag to the server, then the resource server keeps the request inside and use the information captured in that request, which is access point of the client, in order to send a notification whenever there's some status change in the server. Now these are the list of the platform that IoTivity supports. IoTivity supports 9 operating systems on several different hardware platforms, and the keywords colored with the red color are not officially supporting platforms, but I have successfully port IoTivity into the Linux with the ARM or MIPS when I was implementing the home digital appliances. So those are the supporting compilers. Actually, IoTivity can be built on equal or upper version of the GCC 4.6.4. Now this is kind of simple and brief design of the IoTivity stack. From the base layer, you could have connectivity abstraction feature and messaging, and the resource introspection functionality. In the previous session, he mentioned that the IoTivity does not provide a resource introspection feature. There's a two. Actually, we don't have any official resource introspection feature, but we could introspect the resources that resource server has using the collection. So, but we cannot do the data model checking kind of thing. But we could check whether what kind of resources are captured in that resource using the collection. So I could say that's kind of resource introspection feature. From the service layer, we could have some commonly used functionalities, for example, easy setup or grouping resources in local, but also not only the local, but also in the remote. Meaning, for example, if you're a client and if you want to use resource A in a remote and resource B that you have inside, you can make it a collection resource binding 2 different resources with itself. So that's kind of a grouping feature. And these are the libraries that you will have if you build the IoTivity stack. And the libraries with the blue color is the minimum set of libraries they will need to have for your development. The liboctv stack has connection abstraction capabilities and the messaging functionalities there. And the libraries with the red color provides security features. So, for example, if you want to have security feature, for example, if you want to provide ownership, we want to have a ownership transfer feature in order to make this resource server yours so that no others can use it, then you will need to have those libraries with you. And libraries with the black color is the extra libraries. With these libraries, you can build your applications in a more easier way. If you use these libraries, maybe you can minimize the line of codes, maybe 50%. But of course, the size of the binary will be increased because of, as you can see, the library sizes are very big. Okay. Those are the target devices that I've worked on last year, and I'm still working on more other devices. For example, robot cleaner and washer and dryer, and air purifier. As you can see, I have worked on different OSs and hardware platforms. Actually, there is one more thing in the refrigerator. It was ARM, not only ARM, but also I have used MIPS, or hardware platform. Okay. Now I'll explain how you could implement your applications based on the IoTivity. There are two major steps. One is resource modeling, and the other one is implementation. So let's start with the resource modeling. What is resource modeling? Before we talk about resource modeling, we have to talk about what is resource. Resource is a representation of a specific data or the access point of specific functionality. So meaning you can, meaning the resource is a source of data of interest that you want to have, or source of controllability of interest you want to, control. For example, let's say there is a temperature there. Then you could model a resource with the URI temperature so this device has that resource. You could discover a resource, temperature resource on the network, and if you send a GET request to the temperature resource, then you will have data, temperature data. And if you send, POST request to that resource with a, some specific temperature value that you want to change, then the device will receive that data and use it inside and send back results. Whether if it receives that value, then you will say okay. Or if the device does not receive that data, it will say error. I'll give more detailed explanations later. Okay, this is how you start a resource model. So, and then let's talk about the format of the resource. A resource consists with three different components. First one is the URI, is exactly identical to the URL. I mean, not identical, but similar to the URL, which you can use for discovering and assess the feature. The property is characteristics of resource, and there are two different properties. One is resource type, and the other one is interface type. Resource type represents the what kind of data that this resource will have. For example, there is a OIC temperature, which is defined by the OCF specification document. If you use that, I mean, if the resource has a resource type, that means that resource has temperature, attribute temperature, and units and range. That is defined in the OIC specification. So, I mean, whenever you discover a request and resource, and if the resource gives you the resource type OIC.out temperature, then you know what kind of attribute is there. And there's an interface type there. The interface type is how you can get represents how you can get the data from the resource. For example, there is a OIC.if.a and .s that represents that .a is actuator. This resource is actuator type of resource, meaning you can send not only get requests to the resource, but also the post, meaning you can get the data and you can also change the data. But if the resource has if.s, that means this resource is sensor type of device, type of resource. That means you can only send a get request. But if you send a post or something else, then you will get the error. In one resource, you can have multiple resource types and interface types. For example, you could have temperature, not only temperature, but also, for example, you could have binary switch. And binary switch should have attributes named value with a boolean type. So if you add two different resource type in one resource, that means you will have not only temperature, units, and range for the temperature resource type, but also the value with the boolean type for the switch binary thing. But the temperature, resource type start with the keyword OIC is, predefined resource type. So if you want to kind of define your own resource type, then you could, have your own resource type. We have a format to represent that this resource is, vendor-specific resource type. For example, x.company.com.something, meaning it's not specified in the OIC, but it's specified by the vendor. So it's kind of own usage purpose. Not only resource type, but also interface type could have multiple resource interface types. For example, since the actuator type and the sensor type is orthogonal, you cannot have both at the same time. But you could have kind of OIC baseline, for example. The baseline is, meaning if you this resource can share you every information that resource has. For example, if you send a GET request with a query if equal to OIC if.baseline, you will have every information described here. But if you send OIC if.linklist ll, then you will only have the URI, for example. So you can, define your resource with a mixture of this URI, property, and attributes. Not only the property, but also you could add your own attribute into this resource, but you have to follow the format, how to name your own vendor-specific attribute. For example, x.company.com xxx. The reason why we use this kind of naming format is because, if we just use without this format, we may have some conflicts between, resources which is already defined in the OIC and the, resource with the, vendor-defined one. For example, I want to use just attribute named value. But if some resource has resource type ocf.switch.binary, which forces to have value attributes, then it will conflict. That's why. This is a kind of example of resource model with the Jenks-like format. First one has, I'm sorry, the keyword is wrong. /YC+D represents the device. This is well-known URI already defined by the OIC. So with this resource, you can discover a device with a specific device type. As you can see in the LT, there is a OIC.D.air conditioner. That means this, the device with this resource is an air conditioner. So if that resource has wash.d. For example, washer, that means a device with that resource is a, washer kind of thing. Resource with the URI wash/d should have 4 attributes there, which are n, ICV, DNV, and IDI. Those are, n is kind of name of that device, and ICV is version of the IoTivity. No, there's not the IoTivity. Version of the specification, core specification. And DNV is, version of the smart home specification. That's a vertical version of the specification. The DI is a device ID with the UUID version 4 format. And there's another one, the /yc/p, that represents the platform that this device uses. For example, if a device has a Tizen for its own platform, then you can have that information in their resource. I'm using Tizen with the version this version, and this is manufactured by some company. So those you can capture those kind of information in that resource, platform resource, and those well-known resources are already defined in the IoTivity stack. So all you need to do is just provide the information for their resources so that IoTivity can handle the request on their resource automatically. And there are two resources under the well-known resources. Those are power and the temperature. Those resources should be registered from the application. For example, you are trying to implement resource server for the air conditioner. Then the air conditioner should be controlled. I mean, you could control the power or you could control temperature, right? You should be. So then application should define those resources for that kind of feature. With that power resource, you could discover a binary switch on a network and you could control it. With the temperature there, you could discover a temperature resource and you could get the temperature data, and you can also change the temperature data. Okay. This is kind of protocol flow, how you could discover a device using the device resource here. In the client, if you send a GET request to the OI/D on the network with a multicast message, then every resource server with that OI/D will respond with its own data. If it's air conditioner, it will respond with the OIC.air conditioner. If it's washer, then it will respond with the OIC.d.washer. So now you know there are what kind of devices on the network. So you could do the same thing in order to discover what kind of platforms, what kind of device made by some specific companies are on the network. Okay. Okay, those are the kind of brief list of the resource types, device resource types, and its mandated resource types. For example, OIC specification defines that specific resource devices should have some specific resource types. For example, the air conditioner should have ocf.r.switch.binary so that the client can control its power, turn on and off. And also it should have temperature so that the client can get the temperature data and control it. If you look at the oven should have switch binary so that you could control the oven, control the power of the oven. And also you should have temperature. Two different resources with the same OIC temperature resource type. One for get the current temperature data, the other one for control the temperature data. So that's mandated in the OIC. So these are the brief and overall design for the resource server that you want to implement for your own device. Here I have captured for example design for the air conditioner. Let's say there is a microcontroller which represents the features of the air conditioner, and you should implement the resource server which directly communicate with the MICOM of the air conditioner so that you could get data from the MICOM and also control the actual features of the aircon. In order to implement the resource server, you should have the resource model to have explained in the previous slide. So if you want to expose functionality of the air condition, you should have those features with the resource format. For example, if you want to make air condition controllable on the network, if you want to control the power of the air conditioner on the network, you should have a resource with switch binary. And if you want to expose controllability of the temperature, then you should have resource with the OIC temperature resource type, and et cetera, et cetera, et cetera. So, and then once you model all the resources that you want to expose on the network, you have to register into the IoTivity stack so that IoTivity stack could expose on the network. This is how you register your resources on the network. So, for example, if you have 10 multiple resources, resource model, you have to call the OSC credit resources 10 times with the different resources described in your resource model. For example, these are the resource type, interface type, and the URI. This is the callback function that you want to use whenever there was a request delivered to the this device. And these are the kind of characteristics of the resource. If you want to make this resource discoverable on the network, you have to put this flag. If you want to make this resource observable, then you have to put this flag. And this is extra one. If you want to make this resource secured, then you have to put this. If you put this thing, you cannot discover the resource if you don't, provision yourself to the resource server. I'll explain how to provision a resource server from the client side. So only the resource client which has provisioned its ownership to the server can discover this resource. Okay. So this is a kind of flow of the logic that you need to capture in the callback. We call it entity handler. We have to register this callback when you register your resources. So inside the entity handler, there is a logic that you can distinguish, is it the request type or the observe type? The reason why we distinguish between request and observe is because observe is kind of get request of with some special flag. So that's why we distinguish it. I'll explain the details later. So whenever you distinguish that this is a request type, you will need to find out what kind of request type it is. If it's GET, then it's kind of monitoring request, meaning client wants to have that data. If it's POST, that means client wants to change the data. So once you get the request, you have to validate the request, meaning when you send a GET request, you could put a query inside the request. For example, interface type. If you put interface type in the query, for example, OIC if.baseline, that means, okay, I'm the client, I want to have the data, but send me every data related to resource. But if you put interface with the OIC for example, linked list, meaning, okay, I want to have the data related with the URI, not the attribute or a property, but just the URI. So you need to validate the request because resource, if the resource does not support the kind of interface type, then this resource server should send an error. When you find out that the request is a valid one, then use get the data from the microcontroller and create a payload and send it out. If it's post request, there's an extra logic that you need to have in the valid request. Meaning, for example, you need to find out whether the request that you have sent to change is actually providing data changing feature. For example, let's say the temperature, what is all the temperature resource type, the only attribute temperature attribute can be changed. Units and range are read only. So if a client sends a post request with the attribute unit value with the Celsius, then that request is not valid one. The only request with the temperature value with the value something, that is the valued one. So that kind of logic should be captured in the logic and validating the request. And then if you think that this is valid request, then send a, changing a data to microcontroller and then create a payload and send out. And yeah, here's the observe request. If it's not the get, put, post, delete, but observing one, then you have to check whether it's, the client is trying to observe or canceling the observe. If it's just observe one, then you can start the status checking logic, so that every time if that logic finds out, okay, something has changed, then you can send a notification to the observer. And if it's canceling it, you can stop the status checking logic. So yeah, I mean, this is kind of code snippet, how you implement your validation, guest validation, and create a payloads and send out response. Just ignore the codes, but just look at the statement sentences that are captured here with a bold. So here you could, when callback is called, because it's received, you can check whether this is, get request or not. And if it's get request, you can check whether this is support. I mean, this resource supports the interface type in the query. And if it's valid one, then you can do the work. This is kind of code snippet you can use for your implementation. But if it's post, then everything is the same, but you have to check whether there is a, actually read-writable attribute in the request. If it's read-only attributes, then you have to send out an error. But if it's read-writable attributes in the request, then it's a valid one. And if it's valid, then do the work. Okay. So now, with this mechanism, let me explain how the actual features can work. For example, when you buy a device, you need to set up a device, meaning you have to make this device connect to the internet or network. So we call it setup. At first, you have to send a post to the OIC/proof. That means I want this device to connect to this router, AP router. But before you do this, you have to discover a device first. And then once you discover a device, you have to send Y/proof resource on that resource server with the SSID and password. Whenever this server receives this request, then it'll discover the AP on the network with that SSID, specific SSID. And if it's there, they will try to connect to that AP with the, this password, this PIN password. After that, a client can, send the ownership to this device, meaning, okay, from now on, I want to own this device so that no one else can use this device but me. How you do it? You have to send, okay, I'm the client. I want to make you as my device. But in IoTivity, we provide several ways of provisioning. One is just works. The other one is pin-based. Just works means, if I want to make you mine, then okay. Then the server just, responds, okay, from now on, I'm yours. But pin-based is, just server wants to make one more extra thing to make sure that you are valid or not. That means whenever the client sends ownership request with the pin type, then server provide a pin number to the display or whatever is necessary. Then whenever client look at the pin and send that pin through the network again. And then whenever server receives that pin and think this receiving pin is valid, then it create a credential and send it to the client. This credential is created with the pin, so only the client who knows the pin can decrypt it. And then whenever you decrypt the credential, it creates the kind of secret key inside so that you could use for the later session. This is how you set up a device. And this is how you use the features of resource server using the resources. When each setup is done and then resource server is working, then resource server can send the multicast present packet. Present packet with a multicast. So every OIC client on the network will receive the present packet so that it could initiate resource discovery. The resource client can just start resource discovery without receiving the present packet. But if you just because we don't know when the OIC server, resource server will be discovered on the network, so using the present packet from the client side is very useful. So whenever the client receives the present packet, it could initiate the discover. So whenever resource server send a present packet with a multicast, so all the client will initiate resource discovery in order to discover the resource of interest. And then whenever resource server receives their request, then it will provide its resources registered by the application. OIC/RAS is a well-known resource. So with this resource, we can discover resource of resource servers. So every server implemented with the IoTivity stack will have OIC/RAS inside. And so whenever the application registers their resources into the IoTivity stack, then those resources are binded to this resource. So actually, this resource is a collection resource. So when the client sends a GET request on this resource with a multicast, so every resource server on the network will respond with its registered resources. Now you will have, let's assume that you have discovered the resource of interest. Then you can send kind of GET request to get the data of interest to the specific resource with unicast. Then the server will check whether this is this is a temperature resource. Here are the data you want to have. So let me give you the example how it works. This is presented. Okay. And here, if you want to change the temperature data, you can use post request on the resource of interest. Here, if you send the post request on this resource with the attribute temperature with the value 221.5, then resource server will check. I have a resource, temperature resource. I could change the data to the specific value that you have sent. If data is changed, then the server will send response. And if you don't want to send a post request every time you want to have the data, then you can just send observe request to the resource server, and then so that you could receive the notification message every time the data has been changed. If you want to stop receiving the notification from the server, you can send canceling the observe to the server. Then the server will just remove the observe request stored inside, so that it cannot send the response. This is how I implemented resource server for the home appliance devices. So if you have any questions, you can ask. Yes. These slides posted on somewhere? No, but I can share it to you if you need. Can you speak it a bit more loud? Yeah. Okay. Because the client is sending an observe request to the specific resource type, right? So now server knows what kind what kind of resources are observing by some clients. But inside that observe request, there is a access point of the client, IP address and the port and blah 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 thing is already there, captured in there. Actually, it's co-op spec. So whenever this resource server receives the observe request, it stores it inside it. And whenever there's a change, you could use some API named notify all observers. And if you put URI or the handle of that resource into that API, then internally you will get the information of the client and then send it out. Yes.
Question on this slide, the get or discovery. Once you have a presence, you get the URI and the resource type, right? And so it's enough to have a unique capture. Why do we need the logging?
Okay. In this presence packet, you could put URI or resource type or whatever you want to capture inside, so that the client will know, okay, there is a temperature resource type on the network. Yeah, that's one case. But you could just send a kind of present packet without any information. That means, okay, some servers on a network. That means then the client can, okay, some. Because for example, the WASI server here could have more than one resources. That means you cannot put all the resource types in the present packet. That's why. Excuse me?
Why not include that in the standard?
I mean, then, the packet size will be very big. So, I mean, we can do it, but just, just put it, the necessary information, the minimum information there, so that, the client of interest can send a discovery. So, right.
Second question, why do you need ownership?
Oh, that's kind of idea captured by security people. For example, at home, you have your own devices at your home. For example, air conditioner is there. So their concept is they want to make those devices for you to control. For example, husband and wife and children at home. And then once husband, the resource client of the husband, send ownership to the resource server, which is, for example, air conditioner. Now he will be the only one who control the air conditioner. But since wife wants to control the air conditioner as well, so then he could share his ownership to the wife, so that he could also assess and control the air conditioner. But if you want to do it, you have to share the ownership. So with this mechanism, kind of Melanie with the resource client cannot access and control it. He wants to make secure the communication between the. ACL is kind of authorization. For example, there is a kid here, and I have transferred the ownership to the TV, and maybe kids can use TV in order to get some not good contents. So you can authorize some features of the TV so that kids cannot use it. So ACL is kind of authorizing feature, not authentication. Authentication feature is different. Yes. No. Client can discover whenever he wants to discover a resource on the network. But if you use that present packet, then you don't have to just keep sending discovery request whenever you want to, because without a present, the client should send a discovery request with some specific period in order to find the resource of interest on the network. But just not sending that kind of discovery request, but just waiting for the presence on the network, then it could initiate discovery. So it could save resource from the client side. Yes, he was first. Faulty device. Okay. What do you mean by faulty device? protocol perspective, there is a, we are, because we are based on the CoAP, and there is a that kind of specification captured in the CoAP specification. So we follow that kind of thing. But mostly CoAP covers, if there's no such contents, no contents, is forbidden, that kind of error handlings. Not kind of, the low level of error handling thing. So we have that kind of thing. Yes.
It's not so much a question about the protocol, but I mean, it's really great if you have the set point temperature and extra temperature in the room and take care of it.
Oh, yeah, that's either captured by specification people, and that is why, that is because,
So let's say if you have the husband and wife scenario, and then the husband, they both have access, so the husband sets the certain set point, and then his wife cannot even figure out what the point.
oh, the reason why we have two different resources with the same temperature resource type is because, for example, one resource is for sharing the current temperature data, not setting data. And
It is separate.
yeah, separated. Oh, yeah, I'm sorry, but I have to put some other, keywords after in the URI. Temperature, current, and temperature setting, kind of thing.
Yeah, because otherwise it doesn't incorrect, right?
Yes, you're right.
Okay, that makes more sense. Thank you.
Okay, thank you.